Hi, everyone. We're going to get back to it. Today, we've got Sam Nixon from Roadie, who is going to be talking about Agentic Backstage.
Thank you very much. Hopefully everyone can hear me. I've not got a monitor on stage, so I can't hear myself, but you know, who cares? I'm Sam. I work for Roadie. Hopefully everyone's heard of Roadie. If not, we are the people wearing the monstrously orange, or very Dutch orange actually, t-shirts outside the booth there. I work in product and engineering for Roadie. We have been part of the Backstage community since it was open source. So a lot of the plugins that you may have come across, the Argo CD plugin, the RAG plugin that we open sourced a couple of years ago, the Okta provider and things like that. You may have seen our name crop up in a bunch of places. Also, we had the founder, David, give a quick talk a few minutes ago, so you may have seen that. We have been talking at BackstageCon for a few years as well, and so this is going to be pulling on a longer thread of stuff that we've been talking about, specifically with the catalog, but also in the last year, 2 years with AI as well. So we began way back in 2021 doing this stuff. In 2023, we were talking about catalog completeness, that we were seeing evidence from the community that it was a little bit harder to get to a complete catalog, to get to a version of the catalog that you're really happy with, and that all of your engineering teams were happy with and were using and was up to date. A couple of years ago in Paris, we were talking about dynamic catalogs, some tools that we built that helped people not have to write YAML and could go directly to the UI and use that. We also open sourced our implementation of retrieval augmented generation, like the sort of RAG framework for how you could empower your agents to actually take information from Backstage and have more knowledge about your software topology. 2025, we didn't talk about anything because we were busy building agents for everything, as I'm sure a lot of people in this room were also. And so this talk is very much leaning on that 2 years of learning, experimenting, building a lot of stuff. And when I submitted this talk 6 months ago, the idea was that we would open source a lot of that. A few days ago, I recreated most of it using Claude in a day. One of the experiments that we'll run through, I recreated in 38 minutes. And so part of this is just to say, you can build a bunch of this yourself right now. You could probably build it while I'm talking, and you would be able to achieve very similar results. And so the learning of it is as important, or we believe more important, and hopefully we can provide some of that back as a contribution to the community. That last 6 months has been wild and wacky, certainly for us. This is a graph of the interactions that users have versus agents on the Roadie platform. The blue line is agents, right? You can see on certain days we are 100 to 1 agent interactions versus user interactions. Like Backstage can be a fantastically powerful tool to empower agents to interact with your ecosystem, to understand your software topology, and ultimately to act upon it. It's certainly what we've seen from our customers in the last couple of months. This is 2026, so the beginning of this year onwards. The user line is relatively static, right? We have the same amount of users logging in, but just exponentially more agents. And we've crossed that threshold where it's no longer even 50-50. We're seeing many more agent interactions than user interactions. So what have we tried over the last 2 years, and what could you potentially be trying yourselves within your implementation of Backstage if you're self-hosting? We built that vector database for RAG. That was open sourced in 2024. We built a full AI assistant because everyone was building AI assistants last year. Spotify have one, we have one, everyone has one. Every piece of software seems to end up with one. We built MCP servers and released those 6 months ago. We have agents, resources documented in the catalog, generic auto-ingestion providers, agentic relationship building, which I'll touch on later, a gateway, generative UI, vibe-coded templates, everything. We threw a lot at the wall in order to understand what would work, what was useful, and what do agents actually require and need. And the easiest way of explaining this is to go back to an experiment that we ran in 2024, at the beginning of 2025, where we created an assistant and we thought that was going to be great, that was going to be enough. We created it was powered by Claude 4 at that point, and thought that that would be a useful thing for people to use. And so we started to get our customers to use it. And we hit this problem. So it's an example of an alert coming in, just saying that a generic service is down, the payment service is down. Who owns that service, right? A very common question that people will come in and ask about a software catalog. The problem is that this agent doesn't have necessarily that information. The owner is set to be the engineering department, which is obviously kind of unhelpful to actually find out how to remediate any issue with that service. The department itself, it has some information on 134 members. So like, who do you go and talk to for this thing? There's 134 different options. It finds a runbook. So we have a lot of our customers have tech docs and runbooks established within their tech docs, which then the assistant has access to, which in theory is great. But it will be pulling from that common source. And so it's pulling from an engineering department's pretty generic runbook in order to work through a series of steps. No PagerDuty annotation is set on that record. It can't understand what it needs to do to escalate. In order for this agent to work, in this case, this was just prompted by a user, but in order for this agent to work, it needs more information. That information needs to be up to date. And it needs fundamentally, or it would be helpful for that agent to have tools with which to execute some change, right? And so we came up with these kind of basic rules for what would be required in order for this thing to work. And it really comes down to three things. A comprehensive and fresh graph of your software topology. Enhanced and enriched with relationships and additional context which is outside your catalog. You can't bring everything in. There has to be some line around it. You don't necessarily want to represent logs, for example, in your catalog, but it would be really handy if your agent had access to that. And then delivered out in a format that they can actually consume and use. And as a bonus, this sort of pot of gold at the end of this rainbow, the actual tools to do something with that information. So to actually fire a PagerDuty on-call alert, to create a war room, to create the Jira ticket that it was talking about in the runbook. So what do I mean by comprehensive fresh graph of metadata about software? And how do we get to that conclusion? Well, we built some stuff, right? In order to understand how this could best work, we constructed a bunch of experiments, constructed a bunch of production software that we rolled out to customers. Part of that was the RAG implementation, which we changed quite a lot in 2025 to enhance it. The assistant, agent resources in the catalog, and ultimately these ingestion providers. Because ultimately the catalog is a graph already. It is a series, it's embedded in YAML, but it is a series of nodes and edges. So you have catalog info files which document a node within the graph, document this part of your ecosystem, and then it has relationships to other nodes, to other entities in the catalog. The downside with this model is that it is embedded in YAML. It is fundamentally more static than an agent can respond to, and it's tied to individuals within your organization filling it out. And that's a tricky thing to get a lot of people to do and get them to do completely comprehensively, because you need a comprehensive map of this, of your ecosystem in order for it to, for an agent to be able to always find the right connection. And if you are aspiring to have agents that act completely autonomously, then you need that certainty that they will always be able to find at least some connection in your graph. Luckily, Backstage has a pattern for that already. We have providers and processes. I talked about the Okta provider a minute ago. There are a number of them. They are just, we don't have enough. And so if you could, in theory, have providers and processes for everything, if you could dynamically generate your catalog and not have to rely on YAML, then your agents would be able to reference that sort of source of truth, those source of truth systems, and build the graph from there. And that's ultimately where we ended up. That the most straightforward way of doing this is to directly reference sources of truth from a variety of different services, systems, wherever you hold this information. So this is an example stack that we use, GitHub, AWS, Kubernetes, Datadog, PagerDuty, Argo CD. Now, like I said at the beginning, originally I was just going to open source a bunch of these providers, but ultimately this is kind of a job for Claude. Like, we have a good pattern here which Claude knows about and can be used to generate these kind of providers. It does come with overhead, obviously, that you are then maintaining them, but it's a genuinely useful way to get to a kind of complete, in the sense of representing all of the data that you have and all the sources of truth that you have, a complete catalog, which is then extremely useful for agents. What they don't then know about is the relationships between those objects, right? You immediately hit the next problem, that you have entities in your catalog, but they don't know about the connections between each other. You have all the nodes in your graph, but you don't necessarily have relationships and additional context between them. And when we hit this problem, we again reached for the OSS framework, we reached for processes, but we also reached for agents, right? Could an agent draw these connections given a complete catalog, in the sense of all of the entities are there? Can it draw connections between nodes in this sense? And the answer is yes. You can do it either algorithmically, or you can do it with relatively inexpensive agents. You don't need to be throwing Opus 4.6 at this graph. You can do it with Sonnet models. You can do it with some of the Quen models as well. This doesn't need to be an incredibly complex or expensive system to run. And again, you can do a lot of it algorithmically, because these data points already do map relatively nicely to one another. What do we learn about those relationships, though? Well, you need a lot of data, so more entities, the better. The more entities, the more likely it is you will be able to find bridges between two things that you are trying to compare. I'll talk a little bit about an AWS example where this is particularly relevant in a minute, but the general idea is the more the better. The names of the entity providers is particularly useful if you do go an agentic route with building relationships. So being declarative, being descriptive in those names, it makes your life a lot easier. Some degree of human in the loop to verify those relationships are accurate is also extremely useful. Agents will hallucinate from time to time some, integers. Comparing integers across data sources is a very funny thing that they seem to want to do, and build a relationship between the number 0 and the number 0 in some other data source, but you can't blame them for that. And then links to non-ingested sources of truth as well was another thing that we really hit upon, where you do not necessarily want to ingest absolutely everything into your catalog. You can be much more permissive than in the existing catalog, where you end up with a relatively thin representation of your overall ecosystem. You can be much broader, but you're not going to want to pull in everything. You don't necessarily want to pull in logs. You don't necessarily want to pull in everything from like a Prometheus metrics that you have, but you do want to be able to reference out to those points and have some sort of broader edge to the graph that an agent can use to traverse outwards to another system. Things that we found that weren't helpful for this, kinds and constraint schemas and strict hierarchies. Right? If you use the existing Backstage kinds, which hopefully you're all familiar with, component, system, domain, etc. An agent has to understand and logic over what those things are. If you just have a word, or in the sense of a relationship, a more descriptive form for that relationship than like relates to, it will be able to reason much better across those nodes. So I was going to give an AWS example. This is it. If you want to associate your users through to permission sets that they have access to, you actually need to make like 5 or 6 different calls to AWS, and so you end up with these sort of interval data sets, interval entity types. But through that, you can build a nice relationship from an account, permission set, through to groups, group memberships, and down to users. So you can build out, as part of your user entity, a comprehensive understanding of what that user then has access to. And as anyone in a sort of large organization knows, like that's, from a platform perspective, super difficult to actually do if you have a lot of different permission sets going along, a lot of different accounts, or an account hierarchy that's kind of complicated. To be able to say this user has access to this set of resources or this set of accounts can be very useful at sort of tracing what's going on. Right, number 3, they need it all in a format they can use. This one's kind of straightforward. We again built a bunch of different experimentation points with this, including completely generative UI, so enabling the generation of whole plugins, of whole UI components, that kind of thing. And what do we learn? It doesn't matter so much how an agent gets the data out. You can always optimize the tool calls of your MCP server or build a CLI or something. It just needs some means of accessing the data and information. A lot of people are going down the road of like a vector database and doing sort of semantic search over this. Again, we open sourced that a couple of years ago, so feel free to check that out. The point is, it can be anything. They just need some means for doing it. An API call even is all right. The structuring of the report, the actual output, though, is quite important. You want to use the minimal token count in order to give meaningful information across. So have a think about that when you think about this. What we also found, though, is in that 100-to-1 ratio that we're now getting with agents, they're not using the UI. The UI becomes much less useful. The plugin ecosystem that we have both contributed to and sort of fostered and been part of for the last few years just doesn't get interacted with that much. If you have 100 users using one form, which is basically, that's how we think of agents versus humans, right? Everyone's just a user. 100 users using your MCP server and one using your UI, then your UI is not as important as these other forms of interaction. Also, the agents really hate tables for some reason. But yeah, that's the trajectory of just more focus on enabling agents to actually access this information in whatever form you want to take. There's a great debate about whether MCP servers are more efficient, whether CLIs are more efficient. It will go back and forth over the next few years. Ultimately, no one really knows. And it's worth just experimenting with this and figuring out optimal token usage for your use case. Then as a bonus, so the actual ability to interact with your software ecosystem, to make a change within it, is this incredibly powerful thing that you can then unlock because of the combination that Backstage has of the software catalog, but also the scaffolder. You have this dual platform already. Like it can do those two things, and so enabling agents to make those calls through the scaffolder enables a bunch of use cases that then become very useful, right? These agents can actually not just know about your topology, but they can do something to the software that is being represented, such as investigating, resolving incidents, running migrations, scaffolding and deploying new services, the kind of classic scaffolder use case, rotating secrets. They can do a bunch of stuff if they're allowed to both reason over the software that you have, but then actually make a change to it. And again, I've got the reference there. It's sort of in light gray, so maybe it can't be seen, but like the permission system in Backstage is fantastic. It can wrap all of these tool calls in permissions. So you can have the control that is required to make those kind of change, the responsibility on the user and all these kind of things within Backstage. That kind of already exists as part of the ecosystem. And so you can kind of, to come back to our example from earlier, like I reran this a couple of days ago. That first version was from like early 2024 or 2025. And if you just redo the same thing against a catalog which is built on fresh metadata, which has relationships built in, which has the ability to call it via MCP, and has the actions and scaffolder resources to actually make that change, you can do some very interesting stuff. The same alert comes in, it finds the runbook, but it actually has information about when that runbook was updated, so it can be sure that it's reasonably accurate, right? The PagerDuty annotation is set automatically from a PagerDuty ingested entity that the relationships have been built for. It finds the right person on call. It then has actions to go out to Slack and set up a channel. So it sets up the channel. It then has a deep link out to Prometheus, so it can actually access those queries and understand what is happening with that service, and then I've sort of fudged it a little bit at the end by saying that someone merged the do not merge this PR, which is the likely culprit. But again, that kind of output can be dropped directly into Slack. And this is what we do. Like we run support from our phones these days. So we get an on-call message. This flow will execute. We'll get a summary of not just the alert, but what's gone on. As we sort of execute our version of Backstage that we run internally to provide to our clients ultimately. But that's how we support our customers and how you could, in theory, support your customers. So I've rattled through, but that's it. Thank you very much.
Any questions for Sam? Can you come to the microphone? That's pretty cool, though. Good stuff.
It's on, right? Okay, thank you very much for the talk first. So we are refining kind of an incident management agent right now, pretty similar to this one. We also use Backstage as our main catalog. So the question is, do you have already some metrics out of this implementation, like in the resolution time or the amount of incidents you're making it easier for your developers? If you can share something about that.
Yes, but it's not that it's proprietary or secret in any way. It's just that it's a bit of a skewed example. Okay. So we find that we can resolve about 80% of our support requests and on-call alerts via this system without the need for an engineer to actually do anything. But that is skewed heavily by the fact that we are both building the system and in a lot of control here. But you can see those kind of order of magnitude shifts where the actual, especially in an incident management example, like the reason I kind of used it here is it's like such a canonical example, right? You have this information, it can be traversed, and so actually providing that back to a support engineer, even if they still are the person looking at it. For us, the process is the support engineer will get paged, they'll drop into this channel, they'll read the output, and then they will make a determination about whether they are going to escalate or whether they are going to trigger the full incident. Ultimately, what we want to get to is that point is automated as well. So you don't have to have a person triaging it. They're just downstream of that, seeing that as well. But yeah, about 80% faster resolution, or 80% of incidents like that are resolved in some way through this process, and then the 20% still takes as long as the 20% takes.
Thank you very much. Keep it up.
Any more questions? All right. Thank you, Sam. Appreciate it.
Amazing.